Good morning, ladies and gentlemen. I am Saiful Fuada, a researcher from University Center of Excellence on Microelectronics, Institute Teknologi Bandung, Indonesia. Firstly, we would like to deliver the introduction that we apologize for all attendees. We cannot attend this conference due to the specific reason in which we have reported to Professor Yin Ho Chung as a chairman of this special session. So, in this moment, we present by this video, maybe about 10 minutes. We hope that this paper is still able to be published in the NOLTA proceeding. Okay, so, our topic is about investigation of optical interference noise characteristics in visible light communication system. Actually, this paper has been selected as the SPA finalist. Okay, well, ladies and gentlemen, our presentation is divided into 4 sections. The first section is the introduction that discusses the background of this research. The second section is the experimental setup that covers the used components in research. The third section is the results and analysis. And the last section is the conclusion. Okay. So, visible light communication is one of a green communication technology solution which is very potential to be applied in indoor environment due to safer to human health when compared with RF, infrared, and UV communication. Integrated system include full duplex or half duplex scheme of VLC technology can be called as light fidelity or Li-Fi that is inspired by Wi-Fi. The Li-Fi illustration can be seen in this slide. We can see that every devices in the home are connected each other by the light bulb. As an optical communication commonly, VLC is also affected by optical noise interference. This scenario allows to happen when DC sources, such as LED lights, flashlight devices or flashlights from smartphones, and artificial lamps, such as fluorescent and incandescent, are located near to the LED as an information source or around the VLC system area. Therefore, it is very important to know the characteristics of these noises. The effect of ambient light noise to optical links is observed in early 1990. However, they investigate in the infrared communication system. In the world market, especially in Indonesia, nowadays we are seeing the fluorescent with electronic ballast only. In this paper, we present to re-investigate about the characteristics of the global market recently, that are fluorescent, incandescent, and LED. The result of this investigation is very useful in designing resilient receiver circuits for VLC system. As for the lamp that is used as optical interferences is a modern lamp that is commonly used as indoor lighting, such as incandescent, fluorescent without ballast, and then the DC light sources such as flashlight, LED lamp, and also ambient light which comes from sunlight. The detailed specification of the artificial lamps are shown in table below, which is obtained from the product sheet. The experiment method is by placing the interference lamp at a certain distance from the TS circuits. The photodiode will receive the transmitted signal from the interference lamp. The measurement setup is shown in figure 3. Then, we use a flashlight from a smartphone as an ambient light source that is placed around to the receiver system. The scenario for knowing its characteristics are similar to figure 3. As mentioned before, to know the characteristic of ambient light noise, we perform a signal transfer-based OOK modulation via visible light. During data transfer process using OOK signal, the flashlight is given to the receiver system in near distance. According to the results, it shows that DC offset voltage can precede the distortion of received data. Where this condition occurs due to op-amp saturation then make a clipped signal. Therefore, it needs a DC offset removal circuit in the analog front-end receiver system. Well, ladies and gentlemen, in this slide shows the captured result from the oscilloscope to observe the incandescent and fluorescent characteristics. Based on the investigation, the interference lamp also carrying frequency carrier from 100 to 150 Hz with dominant frequency at about 100 Hz. The DC offset voltage that emits by incandescent and fluorescent will be larger when the distance to the photodiode become nearer, because light intensity from both artificial lamps is strong, like LED sources. Ideally, the equation from TIA is shown in equation 1. Then, when using incandescent and fluorescent, the mathematical equation of the TIA circuit can be formulated as shown in equation 2. Because they are not only carrying the DC signal but also carrier signal with a certain frequency, where IPD is the current due to the optical signal from LED sources, then IAMB is the photocurrent due to sunlight and other ambient noises which only has DC component, and I interference is the photocurrent due to the artificial lamps such as conventional incandescent and fluorescent with and without electronic ballast. If, in the indoor environment, use DC source such as LED lamp, I interference factor can be ignored. Okay, ladies and gentlemen, the conclusion is, the ambient light that emitted by LED lamp can affect the received signal in VLC system. The smaller the distance of LED lamp to the photodiode, DC offset voltage will be larger, which cause the information signal to be clipped. Incandescent and fluorescent also carry the DC signal as well as interference signal about 100 to 150 Hz. Well, I think enough. Thank you so much for the attention. Once again, we are very sorry for the inconvenience caused by non-participant from us in NOLTA Conference.